All right, boys and girls, this is our unit on magnetism. So the first thing you need to know is you need to know what a magnet is. And a magnet is any material that attracts iron or any material that has iron, cobalt, or nickel. These are the only three materials that can be attracted to a magnet or that become a magnet is iron, cobalt, or nickel. All other metals like copper or stainless steel will not attract a magnet, which is why your magnets don't stick on a stainless steel fridge. It has to be iron, cobalt, or nickel, or any combination of those three. All magnets have a north and a south pole. Sometimes they're labeled, sometimes they're colored, but they all have a north and a south pole, and these are just the ends of a magnet. Very similar to our positive and our negative ends and our charges, we have a north and a south pole. We use the word attract when we have two magnets that pull together. Just like charges, unlike or opposite poles attract. So a north and a south pole will attract and be pulled in. We use the word repel when two magnets push apart. Like or same poles repel. So this would be a north and a north or a south and a south. They don't want to be next to each other, so they repel. So like repel and opposite attract. This push and pull that we're experiencing with our repulsion and our attraction is called magnetic force. So far, all of this that we've been talking about is very similar to electric charge. We have opposites attracting, we have like repelling, and we also have this magnetic force, which is similar to the electric force. When the magnets get close together, the force increases. The further away, the less the magnets are going to be pulled in. So again, with the magnetic force, distance and closeness matter, just like electric charge. Now, just like electric charge, we have what's called a magnetic field. The magnetic field is just a region around a magnet in which magnetic forces connect. The closer the field lines, which you can see here, the stronger the magnetic field. The magnetic field will always be strongest at the poles. So you can see here that these lines are a lot closer together and these are spread apart. This is what it looks like on a typical bar magnet. The ends are stronger. They have this loop on the side where the north is trying to attract to the south. If you put a north and a south magnet together with about an inch in between, which is what you're doing in one of the labs, you'll see that the poles are trying to connect with each other. That's because opposites attract. If you put two like poles next to each other, like these two north magnets, you'll see these lines are trying to push away. That's because like poles repel. Go ahead and draw these two pictures into your notes right at the bottom so that you could see what the magnetic field lines are supposed to look like for attracting and for repulsion. If something were to enter this magnetic field, this object would be directly pulled in if it was iron, cobalt, or nickel. So this field is where this force will act. So we can actually make temporary magnets by taking an iron, nickel, or cobalt item. Remember, those are the only three metals that can become magnets because those are the only three that are magnetized. So in these materials, we have these groups of atoms, and they form tiny areas called domains. In a magnet, so over here, in a magnet, these domains have to be lined up. If they're not lined up, like in an ordinary object, then we call these unmagnetized. So in normal objects like a nail or a paperclip, all the domains are scrambled together. In a magnet, though, all the domains are going in one direction. If they're going in one direction, that becomes a magnetic property. So they have a magnetic trait to them. Now we can make a magnet by simply taking a magnet and we can strike it in one direction. If we strike it in one direction, the magnetic force in the magnet is pulling these domains to line up. So we can take a nail and the domains are all scrambled, but as we start striking them, you'll notice all the domains are starting to go in one direction. We can also do this by shocking it with electricity. That will also make a temporary magnet. There are three ways that you can destroy a magnet. Dropping it, hammering it, or heating it can demagnetize it. So that's why we need to be careful with our magnets. We don't want to drop it, hammer it, or heat it. That will scramble the domains and make it unmagnetized. Now, cutting a magnet actually does not destroy the magnet. Cutting it in half will just make two smaller magnets with two smaller poles. So cutting a magnet will not demagnetize, just makes two new